Hello, everyone. Welcome to this presentation. I am Nikos, and we are glad to meet again in person after almost 3 years.
Hello. Thank you all for attending, and congrats to the Voxxed team for all the hard work. It feels a bit strange that I can start talking without asking, do you see my screen? So what this talk is about, it's in the next about 40 minutes, we are going to show you the architectural evolution of Workable, a technology company that this year gets into its second decade of life. Workable started 10 years ago with a very clear mission: to make it easy for employers to find the right person for every job, by building a software that would look much different than any existing tool. Those two interfaces that you see are from the dominant players of the ATS marketplace until today. So 10 years ago, every company that would like to hire people had to use those bulk interfaces. Nikos and Spiros, our co-founders, were one of them, that they believed that there must be a better way. So to achieve that mission, they started with a small team that could easily host their all-hands summit in a meeting room. And less than a year after, they proved that an applicant tracking system can also be easy, simple, and beautiful, and also in the cloud. Since then, the team has grown enough. The photo is from our last summer's all-hands summit. And the product is now a complete hiring platform, having attracted more than 25,000 companies around the globe and helping 1.5 million find a job. So in this talk, we have split this journey into 5 generations. On each of them, we will present the 3 basic pillars of our company and how they evolved: our software, our infrastructure, and our people. So let's take it from the beginning. During the summer of 2012, our founding engineer, Zacharakis, bootstraps our core application, starts building the first basic domain that would comprise the first generation of our product, the monolith. Workable starts as a typical multi-tier web application. All the business logic is getting implemented in a single application following the classic MVC architecture on the Ruby on Rails framework. In the data layer, a relation database, as PostgreSQL, is used as a primary persistent layer, and as Solr and Redis are used to support text search and distributed caching. The web interface. The web interface of that first application is built entirely in server-side views. The development lifecycle is simple. Our UI designer was responsible for providing the markup and the assets of each page, while a full-stack engineer would compose them into server-side views and, of course, implement the business logic. Some very client-side scripting is written in CoffeeScript, mainly to support user input validation. CoffeeScript is a flavor for JavaScript simplified that Rails stack provides. About infrastructure of that age. So for an early stage SaaS company like Workable, selecting a cloud provider is equally significant as other decisions like which programming language to use or which framework. So in this first generation, the founding team decides to select Heroku. Heroku is a container-based platform as a service with integrated data services and a very powerful ecosystem for deploying, running, and scaling modern applications. The build and release process of the monolith, among the management of the backing services, are all based in Heroku. The developer-centered philosophy of this platform will reduce significantly the cognitive load of the engineering team, allowing us to focus on the product development. It will also bring another major advantage, as it will push us to comply to a set of principles which will help us improve the way we maintain, deploy, and scale our application in the cloud. Those principles actually consist in a framework which is known as the 12-factor app. The 12-factor app is a methodology defined by the developers of Heroku at 2012 for building cloud-native applications. As it's mentioned in the original book, the motivation of Adam Wiggins, the founder of Heroku, and his team was to raise awareness of some systematic problems they've seen in modern application development, and to offer a set of broad conceptual solutions. As its name suggests, it distills a set of best practices for building cloud-native apps into 12 factors, which cover the full life cycle of the software development. So, during development of how to track the code base, define dependencies and environment, how to build, at runtime of how to execute, expose, scale out, dispose, and monitor, and lastly, how to manage and administer. Adapting the 12-factor methodology and workable on this very early stage enable us to retain a high level of scalability and resilience. Another important factor was that it facilitating the porting of our services between cloud providers, as we will see in the next generations. So after software infrastructure, let's have a look at the third pillar, people. So as you can see, the first team was operating in a flat hierarchy, honoring the famous two-pizza rule. So one product manager, one designer were setting the cadence, and the engineering team reached up to 5 back at that time, writing code in a full-stack manner in Ruby on Rails. It's worth pointing that this scheme included no test or system engineers at all, and the software quality was a shared responsibility among engineers and product managers, while the operational efficiency was monitored through Heroku's toolbox by the engineers. When the first MVP went online, the single deployment unit consisted of about 120,000 lines of code and was maintained in a single repo. So before jumping to the next generation, let's try to summarize how the early engineers this period and some challenges they faced. So as we saw before, the team size was small, but also highly engaged and capable to ensure high levels of productivity. Thankfully, installing stickers in the wall was not that of those. As you can see, it took almost the entire team to properly place them. This picture is from our first offices. After all, they all work in a highly demanding and competitive environment where the product evolves at a very fast pace. The company is still in the early stage, which is often described in the startup jargon as the drunken walk. The period is full of experiments, fast iterations, while trying to find product and market fit, which for an engineering team is translated in a development mode of continuous development and refactoring, as the team trying to scope the most valuable or lovable product. The domain constantly changes, even the basic entities. So on the bright side, the code size is small yet, so the team is able to tackle these challenges. The Rails framework helps them keep a clean architecture with a good separation of concerns, while a rigorous test strategy with high coverage reduces the risk of multiple refactorings. Lastly, an engineering startup at this stage is expected to wear more than one hat in order to help the company succeed. So expect of the tasks that are related to coding, he should also act as a system engineer by upgrading the production database, a test engineer by crafting a stress test suite, or even tasks such as providing customer support or helping install a laptop for a non-technical colleague, which get us to the next product generation,
which will bring some fresh stuff in our architecture. Having secured a strong funding round, the company enters the so-called product market fit stage. The product keeps growing in terms of functionality, setting 2 strategic objectives: to improve user experience and to strengthen the product's position in the wild by integrating with other platforms. In order to meet the first goal, the team starts to build a much more rich user experience, migrating the most popular pages from server-side rendered to the client. The newly joined front-end engineers decide to build the first applications in a framework duet that had gained a lot of traction back then, Backbone and Marionette. A new backend REST API is built in Rails to support the new architecture, while the new solution is built, bundled, and deployed as part of the existing monolith. Following the successful launch of the new rich application, A second SPA will be launched soon to support user journeys from mobile. On the backend side, we take our first steps into the microservices era. The two main drivers for that were a set of product features that didn't fit quite well in the monolith stack and domain. And second, the fact that the backend team was almost doubled at that time. As the title suggests, those first services are settled in the perimeter of our topology. They were either acting as service providers to the core application through REST APIs, or as data processors between external cloud services and the monolith. All services are built on Spring Boot, a framework that most of the team was very familiar with. All services also are fully compliant with the 12-factor principle we previously explained. And finally, they are deployed as stateless services in Heroku. The team topology now remains relatively flat in that period as well. However, there are some significant changes to note. The engineering roles are now more distinct. The front-end engineers take full ownership of the SPA applications, while the backend team is almost doubled and is responsible for the monolith and the microservices maintenance. The first data science team is established with 3 machine learning engineers who are acting as enablers to the rest of the teams. And finally, we start investing in automated end-to-end testing, hiring the first test engineer. So, taking a look at the figures at the end of this period, we will notice that the code grows by almost 3 times as much as the engineering team. In a similar way to the previous period, but with 4 systems in production, infrastructure maintenance and monitoring remain a shared responsibility across the engineering team. So let's have a look at the challenges a team of 20 is now facing. First of all, they can't be fed with 2 pizzas, no matter their size. The fact that the team has grown in a flat structure brings some inefficiencies in coordination and productivity. A very common problem in a team of that size, for example, is that the meetings, such as the daily stand-ups, are starting to take much more time, making everyone feel less productive. Our infrastructure is still based on Heroku, which means that the most common operations, such as a new deployment or scaling of a service, has to be performed manually. Additionally, the lack of robust continuous integration infrastructure makes the developers run the test suite in their machines, which has a negative impact on the development experience. Furthermore, the fact that we started switching to a microservices architecture without having established a good set of end-to-end integration tests makes the team feel less confident as they release new stuff. On the bright side, during this period, we invest some time and resources to explore a new technology stack that had gained much traction at the time, which is Node.js. We took the opportunity to craft a small service that would give a solution to a narrow problem of the marketing team. The marketing team was trying to rely on external tooling, and we jumped in proposing a simple solution implemented by our team. Within a few weeks, as far as I remember, it was just before Christmas holidays, a couple of engineers were able to launch a microservice in the production using this new stack. The experiment was very successful. In fact, this service is still in production with some minor upgrades. Since then, we have open-sourced several libraries and our own battle-tested framework in Node.js, which you can find it in our GitHub account, and it's called Orca. This brings us to the 3rd generation, where a lot of things are evolving beyond the monolith.
So let's first take a look at the big picture. We are in 2016 when the company shifts from the product fit to the hypergrowth stage. The product team is grown by 4 times to support a set of new initiatives, introducing new organizational scheme, which we are going to view later. New application services are introduced to support the ambitious roadmap, which brings a lot of changes to our stack, both in backend and frontend. So, on the frontend side, the first user-based application is launched beyond the monolith in an entirely new stack. In the middle of the JavaScript frameworks war, our front-end team decides to stand to the React side, which now becomes a framework of choice for all the new features, including the core ATS user interface. During the same period, we launched the first version of our native mobile apps on both platforms, iOS and Android, which are supported by the existing REST API with the web clients. On the backend side, a new family of services and web application is getting bootstrapped, supporting a lot of business cases. The team, having gained knowledge from the previous experiment Nikos described, feels much comfortable to invest in the Node.js stack, which becomes the second preferred language after Ruby. The new user-faced applications bring some challenges, as we had also to provide a unified user experience across apps with single sign-on. These requirements triggers the need to extract the user identity domain from the monolith to a distinct service that will act as an identity provider, supporting any user-faced application, including the new native apps. Some radical changes are also performed in our infrastructure. The Heroku platform had been proved as an excellent choice. However, it becomes non-cost effective as the company and the demand for new resources are scaling. During this period, we established our first team with system reliability engineers who start a very ambitious project to migrate our architectures, our applications from Heroku to Amazon EC2 container service. From the operational point of view, the project is executed excellent with no important flows or downtimes. Except for the cost reduction, the fact that we shift to a container-based solution brings some other important benefits, such as it will make our infrastructure more portable and provider agnostic. It will increase the technology parity across all environments, and will give us more control over our resources in terms of capacity, security, configuration, etc. On the dark side of things, this transition will put some stress on the engineering teams as they have to get familiar with new processes, including an in-house orchestrator tool on top of the ECS infrastructure. So, as we mentioned before, in order to support all these new challenges, we established a more hierarchical team structure. A set of cross-functional teams are formed. Each of them gets assigned a specific product area, being responsible for the full execution of the roadmap through an agile process. A typical team would be comprised of a PM, a product designer, up to 3 backend and 3 front-end engineers, and a test engineer. Another team structure, the known chapters, which are based on the skill sets or disciplines, are also formed to embrace consistency and knowledge sharing across their field. In figures, this period finds us with an almost parallel increase of the code and contributors at around 300%, reaching to 1.6 million lines of code. The deployed services are increased by 5 times, and as we mentioned before, we formed the first SRE team. Since we are now in a self-cache infrastructure, without the Heroku supporting us, it becomes essential to employ our first security engineer working as a separate function, responsible for application and infrastructure security, such as assessments, vulnerability mitigation, etc. So, let's summarize this third generation and see some challenges. Starting from the good parts. The new organizational structure we saw embraces autonomy across teams that are able to achieve high levels of productivity. A lot of new innovative features are launched, contributing to the hyper-growth of the company. On the other hand, with the modern UI stack, the new user-faced application brings a much more fresh and clean interface, which makes the existing UI look a bit outdated. In an attempt to modernize the existing interface, the design and the front-end teams are getting trapped in a multi-month facelift project, which will trigger some developments that we are going to see in the next generation. In services, the proliferation of our services from 2 to 20 by retaining the same integration style reveals a very known microservices ADI pattern. The strongly coupling of our services through synchronous communication brings some challenges and inefficiencies, development, testing, provisioning, and the overall resiliency of the platform. And another important challenge we also face this period is of how to efficiently share the state across all services, and more importantly for us, how to share the core domain of our monolith to the rest. In the next generation, we are going to view how we fix this problem. Lastly, the switch to from Heroku to AWS was a great success in terms of cost optimization. However, the in-house tool that was built did not succeed to provide an experience similar to Heroku, causing an increased cognitive load in the engineering teams.
So the fourth generation brings two new development paradigms, both in backend and frontend: event sourcing and design system. In this generation, it became clear that we had to shift to an asynchronous way of communication between our services. First of all, to avoid coupling, to facilitate the state sharing of the monolith, and finally, to empower many more backend engineers to contribute in different code spaces than the Rails monolith. To do so, we found a product area that needed a revamp, and we designed it using event sourcing and state sharing through Kafka. The maturity of the Kafka ecosystem helped all involved teams to adopt to the new design paradigm with great success. We used a managed Kafka service to avoid the overhead of running on our own, and quickly built knowledge around the streaming framework and the various connectors for data sharing across our different data sources. The new project meets all its objectives and becomes a pilot to transform a lot of other integration points, increasing autonomy and resilience of our services. Here we have to mention that the mental shift from the traditional monolith to a state-sharing, Kafka-enabled environment took a lot of internal, fruitful engineering debate, an ingredient that is absolutely essential for the success of such initiatives. It takes time and effort to steer the ship to a different direction. Making such radical changes means you will need strong commitment from all involved parties. In the front-end side, having experienced the painful project of rebranding hundreds of existing pages, both in legacy and new applications, design and front-end chapters come into a consensus that they have to rethink the UI development process. After a lot of research and ideation, they decided to start building a UI design system built on top of the atomic design principles. The atomic design is a mental model created by Brad Frost that helps thinking of user interfaces as a cohesive whole and a collection of parts at the same time. Through the comparison to atoms, molecules, and organisms, we can think of the design of our UI as a composition of self-containing modules put together. A small team of front-end developers and designers start the project, and within a few months, the first shared components are ready to use in their UI storybook. Let's have a look inside. Atoms are basic blocks of the matter, so in the UI world, they serve as foundational building blocks. They include all the basic HTML elements that can't be broken down any further, such as typography or input components or buttons. Molecules are relatively simple groups of UI elements functioning together as a unit. Good examples of this type are a toggle button, a date picker, a drop zone for file uploads. And finally, organisms are relatively complex UI components composed of groups of molecules, atoms, or even organisms. They usually form distinct sections of an interface, and some good examples are a PDF viewer or a rich text editor. Here we see how these shared components are used in real pages to provide a unified experience across our front-end applications. Now, in the self-hosted infrastructure saga, the SRE team, after completing the full transition of all services from Heroku, including the scary migration of our production database, they come to a dilemma, whether they should keep developing our proprietary service orchestrator in AWS or to embark to the cruise ship of Kubernetes. They think wisely, starting the second season of our infra trip, this time to the Google Cloud Platform, which provides a much more mature and native support to the selected stack. In an attempt to align the product teams to the company's priorities, we proceed with some structural changes in our teams as well. We shift from the cross-functional scheme to a more flexible topology, trying to keep the teams in cohesive groups named tribes. The autonomy of the engineering teams is retained, as they undertake the ownership of specific code spaces. In a similar manner, the product owners and designers are assigned specific product user spaces. From the operational standpoint, we perform some changes in our agile process, shifting from 2-week sprints to 6 weeks build cycles, followed by 2 weeks repair cycles, which give the teams a pre-bought time for bug fixing and technical debt. Actually, it's more bug fixing. In figures, this period finds us with a 150% increase in the number of lines of code, while the contributors have increased by 71%, a balanced back-end and front-end horsepower, and a double increase in the number of deployments, 50. The site reliability engineering team has grown to 9 members and is a true enabler for the rest of the engineering teams. We also invested more on in-house security. So let's have a summary of this period. To begin with, the adoption of Kubernetes was really smooth. It is a big open source framework with mature community and was easy for the developers to learn and get help. It is future rich, meaning that we get out of the box canary releases, for example, and many tools have already been integrated into the ecosystem. All the above allow the SRE team to stay lean and scale while enhancing the infrastructure offerings. We managed to double in a year the infrastructure footprint in a cost-effective way. Essentially, we found the right balance between a fully managed solution like Heroku and an in-house container orchestrator. In spite of the fact that data sharing was empowered by Kafka and UI components were streamlined with the design system, not all product areas are on the same page. We still have services that are strongly coupled and areas that were built with the old tech stack. This also affects negatively the development experience. And finally, we see the time to deliver product roadmap items increasing. Is there a way to fix it?
That's a difficult question, but at least we can try. In the 5th generation that we're currently working with, where the main theme of this generation is of rethinking our monolith, or maybe monoliths. So, starting from the front end, if we take a step back and view the front-end evolution of our core product, we'll see that we start from server-side views to SPA and then in the microservices era. In that over time, we will see that this layer gets bigger and bigger, eventually turning into a front-end monolith, which brings all the known inefficiencies of the monolith. Build and test times are increasing, no clear boundaries between the teams, which are all contributing to a big code base. And for us, the problem gets even bigger. If we take into account there's still a lot of legacy code on the older stack, Marionette, jQuery, server-side. All this contribute to a very bad development experience, which overall kills productivity. So is there a better way than that? It looks like there is, so why don't explore micro frontends? It's a term that came up at the end of 2016 by ThoughtWorks, and it extends the concepts of microservices to the front-end world. The idea is to think about the web app as a composition of features that are owned by independent teams. The concept sounds simple, however, there was no clean solution to implement it until recently, when Webpack 5 introduced Module Federation, an innovative mechanism that allows loading of separately compiled applications and runtime. So, borrowing the same principles of the microservices world, this new architecture style will allow the front-end teams to contribute in smaller, more cohesive and maintainable code bases, work in a more decoupled and autonomous way, and unlock the ability to deploy independently from other apps on the monolith. So we have the tools, we have the frameworks. Is there a safe way to get rid of the legacy code? Working in legacy code is painful. So, and someone could say, why don't just rewrite, stop everything and rewrite in our brand new stack? Unfortunately for us, for a product like Workable, this is not an option. It will signal a prolonged feature freeze period, which is not acceptable for our business model. Instead of that, we prefer and try a more incremental strategy to modernize and upgrade our product. It actually has a name for that. Martin Fowler gave it. And his name's Strangler, inspired by the way that the tropical figs are growing up on a host tree, often causing its death. Let's see how this method works in action. So let's suppose that the product team decides to redesign a part of our legacy application in order to provide better experience and some new features to the customers. For the engineering team, this sounds like a great opportunity, for example, to build on a new stack like a Mocha frontend or a microservice and get rid of the legacy painful code. The team starts working on the new app, which is continuously integrated into shadow mode. When the work is considered done or good enough for an MVP, we start diverting traffic to the new component. The route strategy we select might differ per case, so it can be a closed beta program with selected customer or an open beta prompting the user to switch to the new experience and try the new application. In case of backend modules, usually we use canary releases for that purpose, driving a small fraction of traffic to this service and test it. When we are confident that the new module operates as expected, we stop diverting traffic to the legacy. All the users are now using the new application. And in parallel or later, we might start working on placing the less legacy application, following the same strategy. Eventually, when all modules are ported to the new stack, the legacy code may rest in peace. So, to summarize what we saw so far in this journey, to explain our 10 years of evolution, we divided our journey in 5 distinct generations, starting small and monolithic, shifting to microservices and beyond the monolith, scaling with event sourcing and design system, and lastly, trying to adopt micro-frontends. But apart from the software infrastructure, we also examined how our people and their structure evolved these 10 years. Someone might wonder, is there any correlation between team structure and system architecture?
Of course there is. In fact, Conway, during 1968, in his essay about simplifying application development, pointed out that an organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. 50 years after, Conway's law is still critical to understanding the forces at play when organizing teams. In other words, the modern version of Conway law can be summarized as if the architecture of the system and the architecture of the organization are at odds, the architecture of the organization wins. Essentially, anyone who makes decisions about the shape and placement of engineering teams is strongly influencing the software system architecture. If we have managers deciding which services will be built by which teams, we implicitly have managers deciding on the system architecture. So let's look at the 4 most important dimensions one should consider when designing team structures. The first important dimension is team size. A stable grouping of 5 to 9 people who work toward a shared goal as a unit has the potential to be an effective team. Kostas showed earlier the 2 pizzas team size, a concept that was first introduced by Amazon. This limit derives from evolutionary limits on group recognition and trust, known as Dunbar's number, after anthropologist Robin Dunbar, and extends to groupings of teams departments, lines of business, and so on and so forth. Anthropological research shows that the type and depth of relationship we can have with people has clear limits. Around 5 people is the limit of people with whom we can hold close personal relationships and working memory. Around 15 people is the limit we can experience deep trust. Around 50 is the limit with whom we can have mutual trust. And finally, around 150 people is the limit whose capabilities we can remember. To sum up, smaller size fosters trust, and organizational groupings should follow Dunbar's number. The second important dimension when designing team structures is team lifespan. Teams take time to form and be effective. Typically, a team can take from 2 weeks to 3 months or more to become a cohesive unit. As Fred Brooks points out in his classic book, The Mythical Man Month, adding new people to a team doesn't immediately increase its capacity. In fact, it quite possibly reduces the capacity during an initial stage. The communication lines inside the team increase significantly with every new member. There is also an emotional adaptation required, both from new and old team members, in order to understand and accommodate each other's points of view and work habits. This is the known forming, storming, norming, and performing team development model introduced by Tuckman. Teams should be stable, but not static, changing only occasionally when necessary. In typical organizations, people should remain in the same team for 18 months to 2 years, and the team should be given coaching to improve and sustain team cohesion. All in all, the best approach to team lifespans is to keep the team stable. Now we have small, long-lived teams in place. We need to improve team ownership. Team ownership helps to provide continuity of care. Every software system should have exactly one owner. There should be no shared ownership of components, libraries, or code. Teams may use shared services at runtime, but every running service should be owned by only one team. Ownership should not be territorial. Rather, teams should view themselves as stewards of code. The final important dimension, often overlooked when designing team structures, is team cognition. So what is a cognitive load? It is the amount of mental effort being used in the working memory. And there are 3 types of cognitive load. The first one is the intrinsic cognitive load. It refers to the aspects of the fundamental task to the problem space. An example would be the languages used by the teams. For example, are all team members proficient with using C++ or JavaScript or Ruby on Rails? The second cognitive load is the extraneous and relates to the environment in which the task is being done. An example would be, how do I deploy this component? How do I configure the service? Can you remember, as you can remember from the third generation, Workable team members were struggling to learn a new way to deploy services when we migrated from Heroku. You have to be aware of such cross-team challenges and the effect they will have on cognitive load of the teams. The final is the germane cognitive load. This relates to the aspects of the task that need special attention for learning. An example of this would be the complex business logic of the billing subsystem or the implementation of a high-throughput subsystem of an API gateway. You need to train the team members to have adequate knowledge of the language they are using. You need to automate as much as possible the extraneous tasks related to deployment, testing, configuration, to reduce the burden of the extraneous cognitive load, and to give to the teams the right amount of business boundaries they can handle. You can't expect from a team comprised only from associate-level professionals to undertake a big refactoring project. One closing note is that there is no secret sauce and one size fits them all in team structure and architecture. You have to be able to sense your needs and design an effective architecture and an appropriate team structure to support it. Thank you for your time. Any questions? Go ahead. Shall I go? Okay, for the first one, I think that each generation had its own, let's say, limits. One of the most important breakthroughs was the introduction of Kafka, as it allowed different backend teams to operate disjointly and implement product areas responsible for them without having to, having to communicate with and come to the same level. Let's say in Workable we have three main entities. We have jobs, we have candidates, and we have accounts. And in the first and the second generation, all these entities were only inside the monolith. And for other satellite services to get access to them, you had to implement HTTP interfaces, and each time a different business logic should be implemented in the satellite services. The monolith team, the core team, had to go and reach the API, and so you had to have the teams in parallel. This created many bottlenecks, as the core team should, let's say, implement another feature, and they didn't have time, so it kept the other teams slower, and the progress was not so good. So I think that the Kafka and the decoupling of the main entities of our product boosted the performance and boosted the increase of code. On the second question, I think that the teams have 3-4 different types of work. The one type of work they have is the product work. I mean, you have to implement your product roadmap. The other type of work is internal projects that may have. As you showed in the ownership slide, each code space has its own. Each code space has its own evolve. It evolves during time. So you have to think in horizons. If you have the ownership, you think in 3 horizons. The first horizon is what I'm going to implement in the next few weeks. The second horizon is what are the internal projects that I have for the rest of the year. And the third one is, let's say, some experimentation that you need to do. Let's take, for example, a data science team. A data science team may have a whole different velocity than the other teams because they need to experiment and find the right model. So the third, to come back to the types of work of the teams, the first is the product work, the second is the internal project, and then it's configuration and management of management, configuration management of the service. And finally, the fourth is unexpected work. If you have, let's say, many bugs, you have to interrupt your product work and solve the high priority bug. So you have to cater for this kind of work. Have I explained it well? Do you have any extra questions on this?
I will refer to the last slide. You know, there's no one size or one architecture that fits all. At the current stage, or on the generations that we tried the microservices, it made sense. We don't have, a dogmatic approach on that. If we see that it doesn't work, again, as we saw in the morning, the idea is that you have to test, to explore, and see what it works, what it doesn't, and that's, I think, the point of the presentation, that you evolve continuously after testing. There's no...
Building a company isn't a straight line.
Yeah.
right? It isn't a straight line. Thank you very much, gents. Thank you very much to you, Workable. Thank you, folks, for listening to that talk.